So now we are moving our attention to a slightly different topic. So we're done with building for today. I've shown you enough ways of building containers. What I would like to show you is an example of how you can run graphical applications from a container. And I'm picking up the case of RStudio because I believe, especially for this audience, it can be quite of interest, quite attractive. So you have, say you have your R workflows, and you might need to run them both from command line and from a graphical interface. And you would love your workflows to be reproducible, so you have the same versions of the same dependencies for your workflow across these different environments that you're using to run, say, from command line or graphical. And here containers can come handy. So you might use one of these RStudio enabled containers. And here I'm picking one from these Rocker developers I mentioned earlier today. So here you have the R packages embedded in the container. You have RStudio inside the container. You also have Tidyverse, which some of you might know is a set of data science and data analytics packages in R. So this container is quite interesting because it packs all of this all together. And so we're going to see how we can get a working setup with containers and Singularity to actually run a web session of RStudio from a container. And I'm doing this in kind of a trial and error way, because actually this is the way that I had to follow to learn how to have this working. So I hope you can get some learning outcome just by seeing how the whole process look like. And some of the things that I'm showing today that will take a minute to show took me hours, if not days, to figure out. So the starting point was one of the pages in the Rocker project page where they showcase their containers for R, and they even have a page for usage with Singularity. So there was one thing that they mentioned is, okay, this is the command to run from command line to launch a RStudio server. So R server, then you need to specify a communication port, which can be any number. This is just 8787 is just the common one for RStudio. You need this because you will be launching RStudio from a terminal, and then you will access RStudio from a web browser. So you need a communication port, which allows the web browser to find the container or the R server and communicate with it. This is required if this specification of address being *0 is required if you're running this, say, from a cloud instance, and you need to access from your local browser. So, but it doesn't hurt too much to have it always, so it can be there. And these other couple of flags are required just to specify the authentication mode in RStudio. So you want the server to be protected with a password, and so you need those two flags. So this is where I started, and then I'm going to show you how to embed this command with Singularity, with the typical Singularity syntax you have seen before, so Singularity exec, and so on. So let me go back to the terminal now. Just save the name of the Rocker container I'm going to use. So this is how we started. Basically, it was, and I apologize, I need one more piece of information, which is the full syntax I just showed you in the slide. So R server with those 4 flags. This was just taken from the container project Rocker web page. So let's go as we went, say yesterday with Blast and so on. So Singularity exec, the Docker image, and then the command. And then we get this hanging screen, which is not too bad for something that you expect to be a long-running service. So it means it didn't die badly. There was no error. It's just running. It is just a bit disturbing that you run something and you get no feedback at all of what's going on. This is unfortunately a feature of the RStudio server set up from command line. We need to live with that. So what we're going to do now is to try and connect to this R server from my web browser. So what I need here is the IP address of the machine where I am running this RStudio from, so my Nimbus cloud instance. And hopefully I have that in the history of the browser. No, it should be 140. Then you see that after the IP address, we have a colon and then the same port that I specified in the command line. So that's promising. We are getting a welcome screen saying RStudio. So okay, not too bad. But then now the first trouble starts. So we have to specify username and password. And I can tell you the username of my Ubuntu, cloud instance is Ubuntu. But then I'm a bit lost here because actually, first of all, my Ubuntu VM doesn't even have a password because I'm using SSH keys to log in. So I don't even know what to put in here. Okay, so I can try, I can spend the whole rest of this webinar with random strings, but it's not really a clever idea. So we need to specify some credentials for access to this server. So let's go back to the command line. And basically, again, if you start and dig in the instructions and documentation for RStudio, which are not really detailed, to be honest, then you find out that you can sort this out by defining some environment variables. So one called user and one called password, all in capital letters. And we're going to do that with some singularity syntax that we saw yesterday. So even if by default Singularity would pick a variable called user or password, we're going this way because it's more robust. We might need to elevate the level of isolation of this container, and we're going to do that later. So it's just best to use this Singularity specific syntax, which says, okay, you add Singularity env underscore to a variable, and that variable will be carried over when you launch your container. So let's do this. Let's define our user, and let's define our password. Okay, of course, if you do this for production, you will need to possibly create a safer one, a stronger one. And let's try again. So let's launch the server again from the command line and refresh the page. And let's try again. So now I'm going to put the username I just defined in the environment and the password. Oh, and here something is happening. So we got the credentials right, but we got something else wrong. And this very bit, it kind of took me a bit of time to figure out when I was setting this up. Well, you might remember from what we said yesterday in the first webinar that Singularity containers are read-only, so there's no way for applications to write anything in the container if they need to. And this is not a problem for a lot of applications, such as, say, ones that you use for data analysis straight away, single binaries such as BLASTn, BLASTp, SEMTools, whatever. But when you start and run more complex environments, such as a web server, well, these applications normally need to write some configuration file as they run. And that's what's happening here. RStudio is trying to write something in the home directory of its file system, but is unable to. And it's unfortunate that, as I told you before, there's no hint of that. So you get the error in the web server and you get nothing here. So that's why it took me a while to figure that out. And so what we need to do here, so now I've killed the server once more. What we need to do here is to bind mount some directory that can act as the home for this container. In this way, we are getting the read-write that we need. And that's basically similar to what we saw yesterday for BLAST. Right? We bind mounted directories to make input files available and also to be able to write output files there. So now we're doing a similar thing just to provide some space where RStudio can write things. So as I said, the problem lies in the home, but we don't want to bind mount the home of our machine, not to expose any sensible files and data, SSH keys and so on. So we're going to do something different. We're going to bind mount with -p the current directory where we're running from, and call it, and call it home inside the container. And you might remember we saw this yesterday. The default binding syntax is just specifying a directory and it will have the same name in the container. This is a bit less frequent. You don't need to use this often, but this is a good case. So you want to use a directory with a given name in the machine, but it has to have a different name in the container. And you see that here I'm putting home RStudio and not home Ubuntu. And again, this is a little technicality due to the way the Rocker guys developed this image. It's a bit tedious, but it needs to be this way. And actually then I was happy with the syntax. Then I found out that when running on different machines, it was breaking again. And so I figured out that the best way to have this working is actually to mount the directory twice. And the second time you call it with the same name that it has in the host machine. This looks crazy and confusing. If we have time, I can get back in the question time on this. Otherwise, this specific syntax is discussed a bit in the tutorial materials relate to this session today. What I'm doing, I'm just mounting the same directory with two different names to make it work with this container. Let's go. So let's go back to the welcome page. Oh, so it picked the credentials that I had already entered before. Let me do it just from start. Let me log out. So I'm putting the credential in and I'm putting the password. And now I'm in. So we are there. We got a working RStudio setup that you can access from your web browser, but is actually indeed running from a container on my remote cloud instance on the Pawsey cloud. And it's a full working installation. So here you get everything that was installed by the Rocker guys in this tidyverse image. Just to show you a very quick example, I think in the current directory that I launched the container from, there is a sample R script. So here I can go, let's source this readings density. And it would even produce some nice output. Ooh, yeah. So we just run a very quick and short data analysis with R from a graphical web server that runs from a container. And you can get a similar setup from for Jupyter notebooks. I don't have time to walk you through that pathway during the webinar, but if you go back to the online materials that relate to this tutorial, you will find a dedicated session on how to achieve a similar result, Jupyter notebooks for Jupyter fans. Okay, and I have one last little tip for you today, because this is almost the end of the story. We could get RStudio to work. Let's close this up. So let's just shut this session from the command line. And apologies, I forgot to tell you, the way I'm killing this session is simply by hitting Ctrl+C on my keyboard. There was an issue when I was running this setup on a shared system, such as an HPC system. And that's because when RStudio runs, it leaves some files behind on the temporary directory of the machine, so /tmp. Yeah, these guys here, RStudio server and RStudio session, rsession. And unluckily, this directory are not named. They don't say that it's the Ubuntu user that created it. So if this happens in a shared system, you will get conflicts and errors whenever two people try to run this at the same time, and in some occasions even one after the other. So that's kind of a problem. And one way, so let me clean that up right now. So that I show you a good workaround for this. So now they're gone. One way to avoid that from happening, so that you can run this type of session eventually from a shared system, is to add one more flag to the singularity execution command, which is -C. So this stands for contain all. So basically this flag raises the level of isolation of your container runtime in the machine. So now what happens basically now, we are not using anymore a number of system directories that are normally used by Singularity for, say, service purposes, such as creating temporary files. So you add this flag, TMP in the machine is not used anymore. Singularity uses other dedicated locations, and you can run the server by multiple users in a shared system. A byproduct of this is that also the shell environment, so the variables become isolated, which is why we actually defined user and password with the Singularity syntax. Let me show you this last aspect, and then we're done. So now, we are in, and I'm just getting out. Now, if I kill again with Ctrl+C and have a look at the content of TMP, there is no RStudio directory in there. So we're clean. We can run this type of setup in a shared system, and it would work. And let me go back to the slides. So the key points we touched on. So the first one, I actually kind of skipped it just to save time. So if you are running this type of web service, it means you're opening and using some communication port, this 8787 you saw in the setup. If you're running from a cloud instance, you need to ensure that that port is actually accessible, because you might have firewalls and rules that prevent that. So if you normally, the good thing is that any cloud provider for scientific computing will have a protocol and a way to allow you to open these ports, but you need to do that. Otherwise, you won't even get to the welcome screen. If you run this on your local machine, it's not a point at all. It's already sorted out. Other things we did instead, and we kind of troubleshooted on the fly, was to take care of access credentials with user and password, bind mount the home directory somehow to allow RStudio to write its configuration files in there, and then isolate the container from the host for a tidier session which doesn't leave garbage when you close it. And yeah, so this is, again, in the interest of time, we can't go to this now, but there is an extra section in the online tutorial materials that discuss how you can amend and modify this setup if you need the server to be running for a long time, so that when you shut your terminal, you don't kill the server. And there is a dedicated syntax in Singularity to achieve that. I think that's it. The third topic is covered for me, so I'm happy to take any questions.
Okay, so there is a question: how did you build the Docker image locally, but pull it from Docker daemon for converting to Singularity image?
Yes, right. So yeah, you referred to this syntax I did before, right? Mm-hmm. So this is just a kind of a trick. So you're not really, the build was local, as you said, but so Singularity pool can do different things. It can pull and download images not only from online locations like web registries and so on, but also from locally. So, and you achieve the local download by means of this syntax here. So Docker daemon, I think that's here, it's a typo. Docker daemon actually retrieves images from the local Docker installation. And this can look a bit vague because I built the Docker image, but I never showed you where it went, right? So it didn't go in the local directory, and that's because Docker has its own path where it stores images. But the good thing is that there is a Docker syntax where you can see it needs Docker images, that shows you the list of locally available images. And so this lolcow today appeared, if I had run Docker images before the build, it would not have been here. So you build your images locally with Docker, and then you can always retrieve the information on what images you have available locally with Docker images. And that's the information you ultimately use for Singularity Pool. So anything that is here, you can do the example in the other one that is already here, which is Ubuntu 18.04. We just need to remember to give a name. So anything that is in this in the output of Docker images, you can pull it with Singularity Pool and Docker daemon. And hopefully this explanation kind of closes the loop.
All right, thank you. I think there's other questions,
Yeah.
Some good discussion going on, but I think we are coming up on the top of the hour.
Right, so one last slide. So I mentioned it several times. We have online material that cover the contents of this webinar, but even much more than that. So they are on this on the first link here. I'll try and remind today to send the link to Christina so she can share it with all of you. And the second link is just the GitHub repo that basically contains not only the HTML source codes of this tutorial, but also all of the input required to run the examples that we saw yesterday and today. And today we covered the episodes 5 to 7 of this tutorial, and the bonus episode on Jupyter Hub is number 8.